Hello from Chem Help ASAP. Let's see some more IR spectra so we can get comfortable identifying functional groups. This spectrum is very interesting. There is a peak right in the middle of the spectrum. Around 2200 wave numbers. Usually nothing appears here, so a signal here is always significant. This signal is at 2262, just past 2200. That is the region for a nitrile stretch. So this compound likely has a nitrile. What else? The peak at 1645 is interesting. 1640 is the standard value of an alkene. So this compound likely has an alkene. Note that the CH stretch region has some peaks just over 3000. Those are typically sp2CHs. That's another sign of an alkene. Great. These signals around 3500 are tempting to call an alcohol, but alcohols normally have very strong peaks, not little dinky peaks. I don't think these are important. Okay, what is the structure? It is this little molecule with both an alkene and a nitrile. Perfect. Here is our next spectrum. There is a big peak right in the middle of the 1700 region. That is essentially always a carbonyl. What kind? The peak is at 1707. Esters are more like 1740, so it's not an ester. Aldehydes, ketones, and acids are close to 1700. This one is an acid. The giveaway is this broad lump. Very, very broad lump down past 3000. This signal is so broad, it's hard to put a position on the peak. This is the very broad OH of a carboxylic acid. So carboxylic acids will always have both the carbonyl and super broad OH. On top of the OH are some finer peaks. These are all just short of 3000 wave numbers. Let's see, the most intense signal is at 2979 wave numbers. Those are various sp3 CH stretches. There is nothing past 3000, so it looks like this molecule does not have any sp2 CH stretches, so likely no alkenes or aromatic rings. What is the structure? It's this molecule. It only contains a carboxylic acid and some alkyl chains. Here is our final spectrum. We have a big broad peak on the left. This is almost certainly an OH stretch. Is this an alcohol or carboxylic acid? It must be an alcohol. A carboxylic acid would also have a carbonyl around 1710. We do not have that peak, so the molecule can't be an acid. It is an alcohol. Note that we also see a strong absorbance at 1047. That strong signal is likely the alcohol's CO stretch. Anything else? There is this little peak in a typically vacant region at 2200 wave numbers. It sticks out. Its position is 2120, just below 2200. That is the signature of an alkyne. Alkynes normally only appear if they are terminal alkynes, so we should see the SPCH stretch as well. Where is that stretch? It's down around 3200 or 3300 wave numbers. Do we have anything there? Yes, look at this little peak perched on top of the OH signal. This is at 3296. Perfect. That confirms the alkyne. So this molecule has an alkyne and an alcohol. What is the structure? It's that. So we match. We have an alcohol and an alkyne. I hope these sample IR spectra helped you feel more comfortable with reading spectral data and identifying signals from functional groups. Please like, subscribe, or leave a comment. Take care.